Hello, hello. Welcome, everybody. Welcome to our weekly The Routing Loop, the show about anything to do with AWS networking. We got an exciting session for you guys today with Jamie and Leo. I'll let them introduce themselves in a second. My name is Tom. I'll be your host for today. I'm a principal solution architect focusing on networking. And this quarter, every single week, what we're going to do is rerun some of the Chalk Talks from reInvent. So if you haven't, or you have been to reInvent, you might have attended one of the Chalk Talks. If you haven't, they're basically sessions for 60 to 80 people where you get to chat directly with experts and just brainstorm any technology or area they're focusing on with you in that session. And it's going to be a mix of PowerPoint, whiteboarding, open Q&A. So come in with your questions for today's sessions and look up our future shows. There's a QR code that I just popped on the screen. If you scan that, you will see the list of upcoming shows. Yep, Jamie,
Yeah,
perfect.
I'm trying it. Yeah.
Can I point to it? Yes, I can point to it too. Leo, you got to do it now as well. No, wrong way. Yeah.
There you go.
Okay.
I'll look at it.
Cool. So, Jamie, Leo, I'll let you guys introduce yourself. Maybe Jamie, you want to kick off?
Yeah, sure. I'm seeing a bunch of folks from the followers, Ken and Dominic, and that. Hi, guys, and hello to everyone new. Hello from Turkey, not from Turkey, but Buffalo. My name is James Wenzel. Everybody calls me Jamie. I'm also one of the hosts of the show, but today I'm a guest, so we're making Tom do his work. I am also a principal solutions architect, networking focused. Tom and I actually work quite a lot together, as well as the guy to my, I guess it's my left or right, depending on the orientation. Leo, why don't you give us a intro?
Yeah, sure. Hello, guys. My name is Leo. I work here in Brazil as a solutions architect, mainly in the financial industry, and I'm part of the technical community for AWS servicing related to the networking. So it's a pleasure to be here, talk with all of you.
Awesome. Leo, how long have you been with AWS?
Oh, almost 5 years. This year it will be 5 years. Yeah, in the end of the November. In November,
Nice. Yeah.
He's
and I will
younging.
Congratulations.
change my badge color.
Yep. Everybody gets a yellow badge after 5 years
Yeah.
in AWS. Cool.
Sounds cool.
So I'm excited about your session. I think that was one of the highest scored sessions we have on one of the Chalk Talks. So excited about hearing more about mutual TLS and the options that exist in AWS to enable it.
Yeah,
Yeah.
great. Today, I will present about the service that we can use with Mutual TLS on AWS, and it's a talk that me and Jamie presented on reInvent last year. And feel free to ask anything you like. Okay, guys. Before we start talking about the services, let's just do a introduction about what is Mutual TLS. When a client or a computer needs to request a page in a web server, it just send a request and the server do a response about it. Standard request and response process for web application pretty much works as everything else. But when the client needs to have a proof it is correct connecting to the correct web server, the web server then needs to send a certificate to the client saying, well, I am really the one, the web server for example.com, for example. And then this client on his end, on his side, it needs to validate, well, this certificate that I got from the server, is it the one that I trust? And for the client to do this validation, it has a set of certificate trust list, which is the ones it used to validate the client certificate. And this is pretty much the standard TLS communication. So every time you access a web page that has a certificate, it shows a little lock in the browser, it's pretty much that. But what exactly is the mutual TLS? Mutual TLS is the other way around as well. It means that now the client needs to send a proof to the server saying who is the user connecting or sending the request to the server. So the same way happens on the server side. It needs to validate if the certificate the client sends is the one it trusts. So the server gets the certificate and validate against a list of trusted list. It's a certificate authority trust list. So the server validates it. If it's okay, good, got the request. Otherwise, reject because it's not a valid certificate. Okay, so this is pretty much how TLS works and mutual TLS works. So both sides needs to stand up proof about who is the one connecting
Yeah.
and who is the server I'm connecting also. This validation itself, it doesn't need to be done exactly on the server, on the web server itself. It can be on something in the middle, like for example, API gateway, application load balancer, or any other resource, any other services that we can put to get the connection from the customer, from the client side.
So Leo, the regular TLS, I think the whole internet is built on TLS, right? Everywhere you connect, I don't know what the actual
Nowadays it
numbers
is.
are, right? But I think every single site that you connect to these days is going to use TLS to authenticate itself to you
Yep,
as a consumer, right? As well as add some level of encryption when you're connecting to that site.
correct.
So if I'm connecting to, and there's a good question here from Karim El Jamal that I'm kind of feeding towards. Uh, like if I'm connecting to my banking site today, right, or I'm connecting to any website that has HTTPS, I would get the certificate, and then I would have to validate that certificate. You want to talk about first about kind of how that validation happens? How does my machine, how does my browser trust that the certificate I got from some random destinations on the internet, like my, Bank of America, or what's the like why am I trusting it in the first place? So that's the first question I want to discuss, and then I want to follow up in a second with what Karim has asked.
Sure, sure. So when the bank or the company generates a certificate, it's a certificate that we say it's a publicly valid one. It means that it was generated by a certificate authority that is a public one. When I say it's a public one, it means that all those certificate authority certifications, the root from those certificate authorities, they are well known by the browsers. So if you get Chrome, Firefox, those standard browsers, those operational systems, they knows about those certificates because they are from known companies that provide certificate for customers like any bank company does. Okay. For example, when you generate a certificate from ACM at AWS console, it is a public certificate. Okay. So you generate a certificate there, it's a public certificate, and my computer trusts the certificate authority from AWS. So my computer knows it's a good certificate if I get it from a load balancer using the certificate generated by ACM. For example, if I get it from DigiCert or any other certificate authorities, those certificates generated there, they are considered a publicly valid ones.
Got it.
So my browser knows how to validate it mathematically and say, oh, I trust the chain because there is a chain, right? The
So I gotta,
certificate
yeah.
authority, the intermediate one, and then the one I use on my web server, on my company website. And
So I
those chains needs to be validated by my browser.
got it. So I get a certificate from the web server I'm connecting to, but that certificate is signed by another certificate that ultimately is owned by, like, through the chain going up the chain of all the certificates signing other certificates, we're going to get to a public authority that has their certificate embedded in my browser. So that's how the browser can validate all the way to the end and say, hey, you're actually connecting to the real destination.
Necessary
Correct.
chain.
Got it.
Yeah,
So now,
and then
Mhm.
the other one I was going to actually tackle the second one that you were going to bring up as a use case. Like, why would you want to do this? Why do
Yeah.
we need to make sure that our clients are valid of the clients that we are expecting them to be? And
Yeah.
the examples I typically use are things like, well, if you're driving a car like a Tesla or like a BMW or anything that's phoning home, and that company app happens to be on AWS, you want to make sure that the car is getting the update it's supposed to be getting. So it helps validate that that car is who they say they are. Or if you're on a gadget like a phone or something, buying it from an app store, you want to be absolutely sure if you're going to update your phone, change any personal information, all of that stuff that's going to mess with that phone, that phone is who it says it is. The browser on it is who it says it is. So that's where those certificates that get authorized or get validated by public validations, common trusted. As Leo was mentioning, AWS is a common trusted place, but there's VeriSign, there's a bunch of others. We trust what they say is to be true, so that's how, and that's why we would need the clients to actually be verified that those clients actually exist using those same mechanisms in the example here that Leo has shown.
Because if we continue with the example of someone connecting to a banking site, as a user, I never have to provide a certificate to that banking site to validate who I am. What I normally would do is username and password, maybe some second factor authentication from my mobile, but I never have to deal with the now I have to generate some certificate that my banking site would have to see. So ultimately, I think what Karim is saying and what you're saying, Jamie, is that mTLS is most common when it's a more kind of service to service or device to service communication, not really a human, right? A human would, like I've seen examples with VPNs where sometimes humans would be assigned end user certificates that they would use to validate the VPN client, but I think that's still, you could consider that as a piece of software identifying itself rather than the user themselves, right?
Right. No, exactly.
Well, I don't know if it's common in other places, but at least here in Brazil, it's quite common to use it for the government applications when you need to prove it is you. So you generate a client certificate on my computer that's related to my social security number in Brazil. And when I need to sign some request or some declarations to the government, I need to do it using this certificate. Otherwise, they don't allow me to do it. Or they force me to go there in person, showing that, oh, it's Leo who is doing it.
Yeah. And I
And
see
I
there's a
see.
bunch of, go on, Jamie. I think
It's my host
ask
thing.
the same question.
I
Go
can't
for it.
help it. I'm sorry. But yeah,
Go
there's
for it.
questions about latency. Does this add any latency? Now, remember, in networking, anything you do to the packet, if you put a route in place or repeat the packet, any action always causes some latency. So it can't say that there's like zero latency, but these mutual TLS 1.3 is also, if you're talking about general TLS, these have been modified over time to be as lightweight as possible. So even though it does add some latency, especially on the initial authorization and hello, subsequent communications within the flow will be fine.
Exactly.
So just think about that.
Yeah, if you think about it, if you had to identify yourself in any other way, that would also add latency, right? If you need to validate the client somehow, there is going to be some latency added somewhere.
Right.
Yeah, but
I mean,
as
just
Jamie
the
said,
piper has to be paid.
yeah,
Negligible.
it's quite nothing compared to how the journey the user will spend on the application, right? It's just in the beginning of the communication, so it's almost nothing.
And I just want to address Gregory B asking, is a service mesh primary use case for mTLS? That's kind of a different way. Service mesh is a method of service to service communication. mTLS could be a part of its strategy for tying things down. Let's say parts of your service mesh are different organizations or different lines of business that need to be validated on a client space. But having a service mesh itself does not require you to get mTLS, nor does mTLS require you to get a service mesh. It's just basically one device, security device, mTLS, securing down service mesh. So you wouldn't have to worry about that.
But it is a common use case, though. I've seen
It
as
is.
well
No, it is.
where you just, when you set up a service mesh, the sidecar proxies that operate the communication, they identify themselves using mTLS. So they get
Correct.
certificates distributed across the board. And then you're in the business of, I think that's the trickier bit that I think service mesh helps you solve, is how you distribute the certificates across all of your different entities. I don't know if
Right.
we're going to talk about it today, Leo, Jamie, if that's something you guys wanted to talk about later today.
Well, we're going to get really, Leo's going to get into, I know we've been sitting on the first slide now for 15 minutes, but what we're going to get into is how mTLS applies to the different AWS services that we have, right? Because we are at different levels of mTLS on different things. I don't mean levels in terms of versions. I just mean the way that they're implemented and how you can get the most out of it.
Yeah. So okay, let's go. So let's start talking about API Gateway. API Gateway was the first service that supported mTLS at AWS. And API Gateway, it has this kind of a basic architecture where you have the API Gateway in the middle itself. You have the endpoint options in the left and the backend communication in the right. As we are talking about mTLS, we are just talking about the clients communicate with our API. So just about the left side. It means that we don't care so much about the integrations, okay? We want to leverage AWS services like API Gateway to make sure we are getting the correct connections. So our backend doesn't need to do it, doesn't need to wait time doing this validation. And with API Gateway, we have these three types of endpoints: the edge optimized one, the regional endpoints, and the private endpoint. Private endpoint supported custom domain name recently in the last reInvent. Okay, so with edge optimized, we didn't have an option to get the user directly to our endpoint because it uses a kind of a cloud front in front of our API gateway. So the connection from the user doesn't terminate in our endpoint itself. There is something in the middle. So we can't use edge optimized endpoints with API gateway and mTLS. The same way we couldn't use in the past private APIs because for API gateway to work with mTLS, it requires custom domain name. So in the past, only regional endpoints would be permitted to use mTLS. Okay, so the takeaways that we have from API gateway is it always, when it's enabled, it will always requires a API gateway, a mTLS. It means that there is no option for us to say, well, this kind of request I want to have a mTLS, this I don't. So there is no way. As soon as it is configured, everything needs to require a mTLS. Okay, if customer doesn't provide a client certificate, it will fail. The connection will just fail. So client must present an X509 certificate to verify the identity. And it's quite often used with IoT applications because you want to make sure the request comes from a device that you trust, that you provided a certificate for that specific device. So it's a valid request. It's a valid device that wants to talk with your API. And as I said before, it's only supported on custom domains. What exactly it means and how we set up it with API Gateway. The first step is to define the CA chain or Certificate Authority Chain that we configure it as a trusted store pointing to a file in a bucket. So we point a file in a bucket with our trusted store with all the certificate authorities that we trust that can be used as a certificate signing for the mTLS certificate. When we do it, we map this specific trust store with our own API and we enable it in the custom domain. So we configure the custom domain mapping to our trusted store and the custom domain, we enable the mTLS there. When we do it, the API gateway itself is able to request to accept requests from the client with multiple TLS certificates. So it will generate a server-side certificate from the custom domain, and also it will accept the client certificates with the request itself.
So there's one thing I want to bring up too.
Here, guys?
Yeah, there's one thing I wanted to bring up. Kareem Jamali, I said that right? Kareem Jamali? I hope so. Just asked a question. Understanding, yeah, thank you. Understanding correctly, can it be done on a particular path, or is it all or nothing? Just remember what Leo was mentioning is that if you turn on API gateway and it's going to basically, you know, verify that mTLS is there. If it doesn't find mTLS, it will drop. So it basically you're telling API gateway to actively look for mTLS. Now there's one thing I want to make sure that's understood as you get into the second part or the next part, Leo, is about ALB. There's a difference between API gateway where it verifies mTLS and ALB where it validates mTLS. There's a big difference. Verifying basically is it verifies that mTLS is part of the communications path, right? And everything is working the way you want it to be. It doesn't validate the chains. So when you're doing ALB, right, you can't use SHA-1, you have to use SHA-2. It will actually know if you try to put in the incorrect SHA or the incorrect kind of cipher on the key because it is actually validating that key.
Yep.
I'm gonna hand it back to you and shut up now.
I have a follow-up as well on this question because I think this is a little bit there's a bit beyond that I want to clarify.
Sure.
With API gateway, so API gateway itself is a kind of a AWS managed service. So it's not like an application load balancer that you get one load balancer per client. API gateway service is a global service, and then customers get kind of like chunks out of that service to create their APIs. And then within an API, you would configure a bunch of different paths, so methods, and then apply different rules and different backend integrations for those rules. So I think the question here is, at which level do you enable this, and at which level this applies? So since this is, if I understand correctly, since this is based on a domain basis, an API you configure with a unique domain, and if you enable mTLS on that domain, then all of the APIs, all of the paths under that domain are gonna required to bring in client certificate.
So again, if you enable it in the custom domain, from that point beyond, every request requires a client certificate. Otherwise, it will just fail.
Yep. But then if I have a separate domain, a separate API that I deploy, and I don't enable mTLS, then mTLS is not working there.
It's totally fine.
Fair.
Yeah. And as Jamie said, it just verifies that certificate is kind of valid in the meaning that it's not expired and it's issued by the certificate authorities from our trusted store. But it will not check, oh, was this certificate revoked? It will not check because there is no way for API Gateway to do it. It will just say, is it not expired? So it's not beyond the time of the validation for the certificate. And is it issued by the one from my trusted store? If it's so, the request is okay. You can get the details from the certificate on your backend. On the API Gateway itself, you can configure to get the informations from the certificate and send to your backend. On your backend, you can do more validation. It's okay. It's totally fine. Also, if you use Lambda authorization in the API Gateway itself, you can do more validations for the certificate, for the client certificate you got, okay? But the API Gateway itself, it will not validate it for you. It will just verify, is it a good certificate or not? And that's it.
That's very
just to clarify,
yeah.
Lambda. Yeah, the Lambda clarify is like this small piece of code you can run in a small snapshot. We call them Lambdas, and they can be called as a target of both ALB, but of API Gateway as well. And then you can put code in there to do things that you want. You can use your own type of, I think it supports Python, supports Go, it supports Java, different types of code methodologies that you can use to go ahead and work on the ticket or based on a conditional of what has happened with your API. It's pretty powerful.
Yep. I think it's a great call out, the validation versus verification. I wasn't even aware of that. So I didn't realize that all it will do is just validate the certificate. And then I would have to have like something else to do the
on your
additional
back end.
check if I want to look at, if I want to validate, or if I want to verify more information. Now I'm trying to think which one's which.
Verify,
Validate.
validate. Yeah. So you verify that you're using mTLS, but if you need to validate the actual cert, you'd need to do that on your targets or on your back end or wherever that lands, which is very similar to pass-through mode. But I don't want to steal too much of Leo's thunder.
Exactly. Okay, so move on. The next or the newest service that supports mTLS on AWS is application load balance. It was launched 2 years ago in the reInvent 2 years ago, 2023, if I'm not wrong. And application load balancer, it introduced two ways of mode. You can work with pass-through mode and verify mode. Okay, but how exactly it works? The key feature is the client gets the endpoint the same way from the load balancer, and you configure on the listener if it's a mTLS listener or not. Okay, and it can validate the certificate for you or just pass through the certificate to your backend. It means that the ALB itself is capable to do more validation than just verify that's issued by a trusted certificate authority or not. Okay, so in the API gateway, in the application load balancer, you can configure not only the trusted store, but you can also configure a certificate revocation list. So you have the options to do both verify and validation. And the same way as in the API gateway, you can get the client informations from the certificate and pass to your backend as HTTP headers on the channel to your backend to the request. And as I said, it works in two modes. Pass-through mode is one of them, where the ALB itself, it will simple intercept or helps you with the TLS handshake. It means that ALB will handle all the TLS handshake with your clients, get the certificate, and pass to your backend. That's it. It will not validate. It will not check the trusted store. It will not do anything. It will just say, well, okay, got the certificate you send me. I will put the certificate in the HTTP header and send the request to the backend. Pretty much that's it. Okay. And this is the certificate it gets and inject as a HTTP header. So it will always use this kind of HTTP header with the chain of the certifications. It means that it's not only one certificate you will get on your backend, but the chain itself, the root, the intermediate, and the leaf one. Okay, and as you can see, the certificate itself, it's URL encoded. So it's a PAN format URL encoded. So it will not break the HTTP request itself.
So I got a quick question here, Leo. Could you expand a little bit more about what is ALB actually doing? Right. So the pass through, is it going to validate and then pass through? Is it not doing any? What's the difference? Right. I think I did some questions in the chat as well with the use case for the pass through mode.
Well, the use case is when you want to do more logic to validate on your backend. You don't need exactly that ALB do the validation for you. For example, if you want to have a series of specific trusted store or dynamic trusted store, or if you want to use order mechanisms to validate the certificate, that's not just a simple revocation list. So all those use cases are the one for the pass-through mode. It means that it will simply get the certificate, inject as a HTTP header, and send to your backend. It will not check a trusted store. When you configure it, there is no option to configure a trusted store, so it will not check. It will not do a revocation list validation because there is no way to configure it as well. So again, it's a kind of blind way to help you with the TLS communication. So the TLS will terminate on ALB, and from the ALB beyond to your backend, you can just use a standard HTTP request that's not a TLS. Or if you want to do a TLS, it's okay as well, but the certificate will send as a HTTP header, not a TLS request.
Yep. So
Yeah.
just to
So
make sure I clarify a few words of clarification here. So if I don't enable pass-through mode and I don't enable mTLS at all, but the client provides a client certificate, what is the ALB going to do? Is the ALB going to drop that traffic? So I have to enable at least pass-through mode to be able to accept mTLS traffic. And with pass-through mode, I'm doing nothing with it as an ALB. I'm just going, hey, dude, I accept your mTLS. I don't care about it. I'm just going to pass it through. If it wasn't enabled, the ALB would just drop or not properly establish the TLS connection. Is that the way
right.
to think about it?
Yeah, so think about ALB also like verify mode, when we talked about verify versus validation. Pass-through mode is kind of like the verify mode for ALB, and it will send the certificate chain from the client back to the targets. And I believe it sends 4 deep on the chain. And one of the main use cases for this too is, let's say that that chain that you're sending to the back end goes through the rest of your application. That chain almost becomes an ID for the session handling of whoever made the original call, and that ID is preserved throughout the entire workings in the application. So that if you're buying a car, if you're doing this, if you're doing, making changes, that ID is your verification through the whole entire process of what you're doing, all on the back end.
But the pass-through mode to me sounds like it's worse than what API Gateway is doing, right? Because API Gateway at least verifies the chain is correct, whereas here the pass-through mode is doing no verification whatsoever other than accepting
Correct.
mTLS client information. At least it's basically telling ALB there's going to be mTLS happening, and
Right.
so be aware it's happening, but you don't validate, capture everything, pass it on to the backend.
Yeah,
And pass the chains, right? You're
Yeah.
passing the whole chains.
Passing the chain, yeah. So capture all the information about the certificate, the client certificate as well as the certificate chain, and then pass it on to the backend and let the backend verify.
yeah.
Correct.
Remember
And
that
do
I
it.
said.
Go ahead.
Remember that I said in the API gateway, when you enable it, you are forced to send a client certificate. In the pass-through mode, you don't have it. It means that if you send a request with a client certificate, this HTTP header will go to your backend. But if you send a request without any client certificate, it can still be a valid request. But on your backend, you will not see this HTTP header.
Yep.
Okay, so it's not forced way to get the client certificate as it is in the API gateway.
Love it. And I think this feeds to what Dominic here is asking about, maybe this being a really good mode for when you want to switch to mTLS and you're starting, and you might have clients that have and don't have mTLS. Would that be a fair thing to say, or
It
would
would
the
be,
Mhm.
yeah, I would say that would be fair, but just keep in mind too that if your backends are doing most of the validation and all the certification, all that stuff, just make sure it has the horsepower to do it. And then when you want to validate and when you want to move on further, like you can do all sorts, especially I know, Dominic, you're using service meshes and stuff. You can split off traffic and move it and do the actual front end stuff later. And then your back end should get lighter. You shouldn't have to process quite as much, but it can definitely be used in a form of, okay, we're going to start using mTLS. But then keep in mind too that you have to also add that extra code into your app if you're doing pass-through mode,
Yeah,
because the ALB is going to do nothing.
the main points to use managed service to handle multiple TLS for you is exactly to alleviate this load from your workloads. You don't want to spend your CPUs and memory to handling all the TLS and cryptographic stuffs for your communications. You just want to do your logic. You just want to get the request, do your business, and send a response. That's it. All the technical stuff to handle the cryptography and so on, relieve it to some managed service.
Got it. And there's another question on the thing that I don't think we really touched too much on. We talked about the server certificates, in most cases being public certificates if it's on the internet. But Karim here has a really good question about, does this need to be public certificates, right? Because for mutual TLS or the client side certificates, it usually would be a private certificate authority rather than a public, right?
Correct.
Yep. Well, it doesn't need to be a public, but if it's a private certificate, the authority that issued the certificate needs to be well known by your computer, by your browser. So it's common for companies like us in the AWS. They generate some kind of certificate in the internal authority, and it's pushed to our computers via some management tools. It means that from this point beyond, our computers knows and trust this internal certificate authority. So if I access a website that has a certificate that was issued by this internal authority, my browser will trust them, will know it and trust them. And mTLS is the same. So if they issue a certificate that identify me, Leo, as an employee, and when I access any application, I will provide this client certificate, and they will trust it as well because it was issued by the internal certificate authority.
Got it. So usually it would be for client certificate. So for server certificate, the most common scenario is it's going to be a public certificate, but you can have private, but it requires a little bit more work. For client certificates, it sounds like it's probably most cases it's going to be a private certificate authority signing it. So then you need to tell ALB or whatever is the other side about this certificate authority, so then it can validate the incoming client certificates.
Exactly. As
Talking
the
about the next
certificate,
slide.
Perfect.
yeah,
Yep.
exactly. That's exactly how it works with the verify mode. In the verify mode, LB it does the two ways validation. It gets the TLS, terminates the TLS for you, get the client certificate and verify on the trusted store, and also it can verify in the revocation list because the certificate was issued yesterday or 1 week ago, and for any reason it was revoked yesterday. So if I try to use it today, the certificate itself is still valid in this time frame. It's not expired, okay? Because it's just 1 week. Usually it validates almost 1 year. But as it was revoked, my application load balancer should not trust it anymore, should not accept it as a valid request. So when it validates against the revocation list, it will know that this certificate was revoked yesterday, and it will simply reject the request. It will say, sorry, I can't accept your request because your certificate is not accepted anymore. And the same is valid here. It gets the metadata from the certificate, injects on the HTTP header, and forwards to the backend, where those are the HTTP headers it will use. The same mechanism applies here, where the certificate itself, it is PAM URL encoded and injected in the HTTP header for the backend. And as you can see, you have more informations from the certificate because now ALB just not got the certificate and forwarded it. It really got the certificate, opened it, checked if it's valid or not, checked against revocation list, and got all the details required for it to do those validations and verifications.
So a quick plug here too is that one of the feedbacks we got when we first released the service a couple of years ago is that sometimes as a customer you may want to change the serial number, or you may want to add or remove something that's within some of these headers. So ALB has recently released a feature that allows you to manipulate these headers. There's 10 headers that you can manipulate. 2 TLS, these particular mTLS headers And then you can also do, I think they call them OCRs, or the ones that are help you dictate to your CDN. So if something here doesn't jibe exactly the way that you need when it comes to like X Amazon mTLS to your backend, there is a feature out there where you can do some manipulation to make sure it can fit.
Yeah, I think it's you can manipulate the name of the header, right? If I remember
Correct.
correctly.
Yeah, you can't. You're not
So
doing a full header insert and mishmash, but you basically the values of the header you can actually change.
yeah, so the value itself. So actually, the value itself. So like the not before. If we look at the X Amazon mTLS client set validity, you probably wouldn't want to be changing the value, and I don't think you can change the value today. But if your application is expecting a particular header already to validate, to look at the validity, and you don't like to have to modify all the applications to now look for X Amazon mTLS client cert leaf or client cert validity, but they're already configured to look for headers called, validity or cert validity, you can modify the name of that header and it will work.
Correct. That's it.
Sweet. Yeah.
Because the value from those HTTP headers, they are done automatically from the certificate information itself. But the name of the header itself, those you can manipulate nowadays.
Yeah. Do we want to, I don't know if we have that in additional slides, but do we maybe want to go back a slide and talk about like end-to-end, what's happening here from a point of view of like, I have an ALB, I have a client, I have the targets. What do I do to get this all
So
configured? I don't know if you have slides for that or if it's,
yeah, I have it
oh yeah,
here.
We do.
amazing.
How
Yeah,
to
so,
set up and how it works. So when we set up a mTLS on ALB, first we need to configure a trusted store that now it's composed not only by a certificate authority chain, but also by a revocation list. And the same applies here. We do it using an S3 bucket. And when we configure this trusted store, we attach this trusted store to our listener. So we don't attach it exactly to the load balancer itself, but to the listener, because not all listeners needs to be done with a mTLS. You can have a load balancer with more than one listener, where some will be ADTPS, others will be a plain ADTTP. So
one thing too, I just want to put in, Karim Jamali was asking, so ALB can actually validate public as well as private certs, assuming from ACM. So what Leo is talking about here is we're using an S3 bucket. So to date, it doesn't come from an ACM. You actually load your revocation list and your CA chain in an S3 bucket, and then the trust store will import that from the S3 bucket.
yeah, which kind of makes sense because ACM is more used for generating certificates, public certificates most often, whereas this is, you just need to have a place for ALB to go and say, okay, I'm seeing a certificate, now I need to validate it. Show me where is the certificate chain and the list that eventually will sign the certificates I'm seeing from the client.
yeah, ACM is for you to get the server side certificate and associate it with your listener in the load balancer, but not to get a list of authorities that you trust. When the list of authority you trust comes from a file inside a bucket.
Got it. And then the listener, for the folks that maybe don't know where, that's ultimately a port that
Exactly.
the load balancer is accepting connections on and then doing something with those connections.
And
Exactly.
right now, ALB supports mTLS on 2 listeners.
At the same time, you mean? So I can have like 443 and then maybe 8443, and then I can have, yeah.
Correct. So that's the limit. So if you need to go beyond 2 listeners, you need to talk about sharding, and that's when you get like myself or Tom or Leo involved and ask for that kind of help. But to keep it simple, yeah.
And so we got our trusted store, we attach it to our listener, then we enable mTLS in our ADTPS listener. From this point beyond, users are allowed to send a request to our application load balancer with a client certificate. So the user sends this request to our application load balancer with a client certificate. Application load balancer get the certificate, get the metadata from it, injected it in the HTTP header, and send to the backend. So in the backend, it will not get the certificate in the request itself. You will get the details on it in the header of your request. Okay? Because ALB is the one that intercepted your connection, got the certificate, and then send the request to your backend. Clear?
Clear. So ALB is ultimately terminating the TCP connection as well as TLS connection.
Exactly.
And that's why it has access to all of the information inside. It negotiates TLS with the client. Got it. And
Still acts as
the
a proxy.
information passed on the headers that you were showing us a second ago with the ex-Amazon headers.
TLS.
Yeah.
Yeah. So you have the power on your side, on your backend side, to still do more validations if you wish. Okay. You don't need to just rely on the verification and validation that was done by ALB. If you want to apply more logic, it's okay. Pretty sure you can do it. But all the heavy lift to handle the TLS connection, the cryptographic stuff to validate the handshake for TLS, it was done by LB. You don't need to care about it.
Yeah. I got two questions here. I think one goes back to what Dominic mentioned earlier. In this scenario, if it's full on verification or validation?
Verification.
Verification. So if a client doesn't have mTLS and connects to TLS, a listener that expects mTLS, is ALB going to drop it or accept that traffic?
It will drop. It will
This
not
in this one
drop
it will
if
drop.
it's in pass-through. In pass-through, you can send with or without. But in the verify mode, just with. There is no way to send without a client certificate.
Okay.
Yeah, if
That
you
makes sense.
turn it on one of the two listeners, and that listener does not get the validation of mTLS, it drops it.
Yep.
Clear. Yeah, that makes sense. And then I guess, so do you see a lot of customers on the back end doing additional validation? Because it seems like if you're offloading that heavy lifting to the ALB, you probably, you can offload that unnecessary cycles from your backends having to deal with the same thing.
Yeah. A lot of times when you're going to start seeing folks doing the pass-through mode and they're doing all that heavy lifting on their back end, there's a lot of regulatory reasons of why that's being done, right? At least what I'm seeing from talking with customers, we're talking like FinServ, healthcare, government. That's really where that's done. Or again, if you have like a connected car, like a driverless taxi, where everything has to be absolutely validated and the ID of the device has to be passed through everywhere, you're going to see that there. For most of our like bank, standard bank communications, or from like purchasing from, like, again, app stores or anything like that, standard mTLS is usually used. So the oddly enough, right, the tighter the security that is required is more where more people use the pass through, because they have to do all these extra things that our managed service may or may not do, or we don't even have visibility into their workload to be able to do.
Got it. And then I guess there's one other item with the undifferentiated heavy lifting that I don't think we help with, is that distribution of client certificates and dealing with client certificates, right?
Yeah, at
Yeah,
least not
yeah,
yet.
yeah. So one of the things that we've been giving advice on, especially that you see there's this revocation list here, and every time you make a change to that revocation list on your S3 bucket, and this is a very good point, Tom, it does not automatically go to the ALBs that had referenced that in their trust stores. You have to actually actively go and do this. So what we've seen some folks do is in S3, you have the idea, the concept of being able to do a trigger based on a change of anything in your block store. So what we find some folks have been doing, they've been pretty savvy, is they'll identify all of these S3 buckets that feed specific trust stores. They'll put in a trigger to go ahead and trigger a Lambda, which we mentioned earlier, which will send an API call to the correct number. They usually reference something like DynamoDB, which is our flat key pair database, and say, okay, I need all of these ALBs now to import because I made a change of my revocation list. I've added something, or I've removed something, and it goes ahead and automatically updates. Otherwise, as you said, Tom, you're going to go to all of your ALBs, and then you're going to do your imports for all of the things that you've done. So scalability wise, we strongly encourage you to take advantage of API calls back and forth to S3 to go ahead and do that re-import of your data store or your trust store.
And have you seen private certificate authority? So AWS service used there for generating client certificates. Is there some native integrations there between ALB and private certificates authority?
So I can't talk about roadmap items, but today it's fairly manual, like I said, or programming around. But this is definitely something that customers have identified as a rough edge, and we're looking at different ways to improve that.
Yep, it
Yeah,
would be nice, right? Because if private
Mhm.
certificate authority already gives you the ability to generate client certs, and then if you can
Right.
just plummet the CA chain straight from there, it would have been a nice integration.
exactly.
Yeah. So the first thing we needed to do, if you remember correctly, about 2 years ago, there was this guy that said that this was not coming out and that he was going to owe me a beer if it did. Not mentioning Tom's name, but it took a lot to get this out the door too, because a lot of customers, especially when you're talking about security and mTLS, they have varying requirements, and this is why we broke it down to verify mode and pass through mode, so we can kind of get most. We couldn't grab all. And then same thing with the features. That's why we came out afterwards with the header manipulation. There's more things that were coming out to constantly improve, but we needed to get the function or the feature out the door.
Cool. Yep.
Yeah.
Okay. I think we have 10 minutes left. I think you guys still have some
Yeah, I
topics.
still have some services to talking about. The next
We'll let you
service
go
that
the quick mouth.
great. The next service that supports mTLS is VPC Lattice. With VPC Lattice, it supports the same way like ALB. It supports different listeners, and one of those listeners is a TLS listener. It means that when you configure the TLS listener, you are instructing the VPC Lattice to get this request and send it directly to your backend. It means that the lattice itself, it will not intercept the traffic to do anything in the middle. And as we are talking that the request will go directly to your backend, it means that your backend is the one that needs to be capable to request to get the request with a proper certificate. It means that you will not be able to use Lambda as your target, for example, because Lambda doesn't get the request with a certificate there. Lambda just get a JSON as a request. So it's not supported by the Lambda itself, okay? And for the Lattice to works, it works pretty much like a pass-through mode from the ALB. It means that it will not do the validation or the verification or anything for you. It will just helps you with the TLS connection and sends the request to your backend. So your backend is the one that needs to be capable enough to get this load and do the cryptographic stuffs related to the handshake with the request. And for your target to support it, it needs to be a TCP target group. You can't use it with a HTTP or HTTPS target group because, again, you need to get a proper request with a client certificate there. Okay,
So
and
it's slightly
sorry,
different, I would say, than the application load balancer pass-through, because on the application load balancer, we're terminating TLS and negotiating the TLS handshake on the ALB while passing on all the mTLS information to the backend. Whereas with Lattice, the TLS pass-through is a full-on pass-through. So I don't think Lattice actually terminates TLS. It looks
exactly,
at the SNI and then it will, based on that, it will pass it on to the appropriate targets.
correct. That's
That's
it.
right.
And it's a very common situation for service to service communication. Like we said for service mesh before, it's a pretty much way to do with Lattice, where you have two different services that communicates between them, and one needs to prove who is the other. Okay.
Yeah, I think Lattice is a whole bigger conversation, because I know we're
Yes.
Oh
introducing. We
yeah.
got 5 minutes left, and we're talking about Lattice as if everybody's aware of it.
Yeah.
But I think we have a separate session later this quarter about Lattice. So yeah, guys, watch this space. I can flash the QR code for our page again here if you're interested in seeing what's coming. There will be a session on Lattice. So
And we'll probably
Perfect.
talk about Lattice throughout most of the year too, because that's a service that's getting a lot of work and things on.
And it's a very good service, guys. You should really pay attention to it.
All
Well,
right, tell us when to use it.
exactly. We gives you a matrix about when to use it between different services that supports mTLS or TLS in general and how it works. So when we are talking about the client authentication for API gateway, it's done by the API gateway itself. Okay, and with Lambda authorizer, you can do some more uh, control or validation stuffs, but pretty much the backend is the one responsible to do all the authorization stuffs. And when we talk about ALB with multi-TLS in pass-through mode, it's done by the backend because ALB did nothing. It just got the certificate and passed through. So it didn't do any authentication or authorization stuffs. But when we are talking about ALB with multi-TLS in verify mode, it's done by the ALB itself. So your backend doesn't need to care about it. It doesn't mean you don't need to do more verification and more authorization logic, okay? But at least the client authentication, it was done by the ALB itself. And for ANB and Lattice, it's pretty much the same. It's done by the target itself, by your backend, because everything just pass from the client to your backend. And when we talk about the client's TLS session termination, with API Gateway, it's done by AWS Managed Services, so you don't need to care or to work on it. With ALB in pass-through mode, it's the same. It's done by ALB itself. Your target doesn't need to do anything. With verify mode, the same. ALB does it. You don't need to care on your backend. But with NB or Lattice, again, everything passed through the backend. So your backend is the one responsible to do the client TLS termination. So your backend is the one that needs to be capable to handle it. When I say capable, I mean you need to have CPU enough, memory enough to do all those TLS connections. And routing rules. We have routing rules in the API gateway, the ones that are available in the API gateway itself, where you can put there. We have the routing options in the application level for ALB. So in the pass-through mode and also in the verify mode, you have the application level routing rules there that can be used. And for the NLB and Lattice is the one available just basically on the port itself, because again, it doesn't do any kind of a connection termination. So it will not do any rules there for you, just related to the listeners on different ports and protocols that you specify there. And pretty much, guys, that's it that we had today for multi-TLS and AWS services.
Wow, I'm impressed with the timing. I think it's the first time where
That's perfect.
I perfectly fit into the time slot. Leo, Jamie, thank you so much for joining and running the session. Super informative. Thanks everybody else for joining, and we'll see you next week.
See you
Thank you,
guys next
guys. I
week.
appreciate your time.